Okay, here's your pre-quiz for chapter 7. Uh, we have simplifying right here. All we want to do, since it's quadratic, we just want to factor. So we factor the top. And what times what is 4, but subtracts the 3? That'd be positive 4 and a negative 1. And on bottom, what times what is 12, but adds to 7? That would be a 4, and that would be a 3. So x plus 3, x plus 4. Now, since I'm multiplying now, since I factored, now I'm multiplying, I can cancel my like factor, so x plus 4 on top and an x plus 4 on bottom, so they're going to cancel. So then here I just have an x minus 1 over x plus 3. And so that is simplified. If I want to find my restrictions, what x cannot be, then before I cancel, I want to set x plus 4 equal to 0, and I want to put x plus 3 equal to 0, and I want to solve for x, so x cannot be negative 4, and x cannot be negative 3. On the second example, here on bottom, you might have to switch yours. It needs to be a 13 there, because x minus 2 and x plus 15 gets you to positive 13. And then on top, I can't cancel, right? Because I can't cab it, but I can factor out an x out of both of these. So I pull out an x and I get an x plus 15. Now I have x plus 15 on top and an x plus 15 on bottom, cancel, and I get x over x minus 2. Now this is subtraction on bottom, and this is just an x on top. I cannot cancel those x's because I can only cancel when I'm being multiplied. That's why I factor first, so then I can cancel. Okay, and then again, if I was asked for what are my restrictions or what is my domain, right? So my domain would be everything except for what makes the denominator 0. So if I plug in 2, that would make the denominator 0 or negative 15. So x can be everything except x cannot be 2 and x cannot be negative 15 if I was to list my domain. But there's my simplification for these two problems. Okay, next one, simplifying again. I'm looking for like factors to cancel, right? So I can only cancel because I have plus and minus and plus. I can only cancel if they're being multiplied, right? But they're being added and subtracted, right? So on top here, I can factor out an x on both of those. So I get on top, I get x plus 3 on top, and the x comes out. So now I can cancel because now I'm multiplying there. So I can cancel x plus 3 on top and an x plus 3 on bottom here. So I can cancel these two because now it's being multiplied, right? So now I can go ahead and multiply across. So x times x plus 2 and then over x minus 2. I cannot cancel these, even though there's 2 and 2 and x. I can't cancel them because they're not exact the same factors. So on top of this one, I can factor this to an x an x plus 2, an x plus 2, and an x plus 1. And then on bottom, I don't know why it keeps doing that. Okay, and then I have a times x plus 3, and on here I have x plus 1, and then on bottom of this is an x plus 2. All right, so x plus 2. So this will cancel because top and bottom, again, I'm being multiplied. That's why I get a cancel them, and then an x plus 1 and x plus 1. So I just get left with a 1 on bottom and an x plus 3 on top. So I just get x plus 3 over 1, or I can just leave it like that. Okay, so there's a simplification when I have kind of quadratics or terms on bottom, like multiple terms. On number 3, you don't have multiple terms. It's one term. So notice there's no plus or minus on any of these, right? So that's why I can just cancel x's and cancel y's and all that stuff, is because it's being multiplied, right? So I keep the first one the same. And because I'm dividing, I flip it and I multiply by the reciprocal, okay? So 12 over y to the 4th over x times, now I can times by x cubed over 3y squared. So since this is all multiplication, I get to cancel one of these x's and this x down here. So that means I'm left with x squared on top, and then I can cancel these two y's with two of these y's. So I get left with y squared, and then I can cancel my numbers. But again, this is division, right? So 12 on top, 3 on bottom. I'm really taking 12 divided by 3, right? Or breaking 12 down into 4 times 3 and then canceling the 3's. So I get left with an x squared, a y squared on top, and a 4. So I get left with 4y, or I probably should say x first. 4x squared y squared. And the second one, same thing. I'm just going to flip that second fraction. So I'm going to flip this second fraction and make it multiplication. Okay, so then I'm going to get 8. I probably should say what it is. Y to the fourth. 8y to the fourth x over 12x to the fourth. Now I can cancel. I have an x cubed and x squared on bottom. So really, I could multiply straight across. Now that that's gone, I flipped it. So I could take 27 times 8, or I can just leave it as 27 times 8. X to the third x, that means x to the fourth on top, because I add exponents when I'm multiplying, right? So y to the first, y to the fourth, so that is y to the fifth. And then on bottom, I have a 12 times 3, just 3 times 12, and just leave it like that. And then I have y squared, no y's over here, so it's just 1y squared. And then x squared x, that means I have an x cubed. And now I can go ahead and cancel on top and bottom. So you can either cross cancel, like number 3, or over here, you can multiply it straight across, right? So my y's, I have 5 y's. I'm going to cancel them with 2 down here, so that means I have y cubed on top. So y cubed on top. And then on bottom, I have an x cubed and a y to the fourth, or x to the fourth, sorry. So I'm left with one x on top. Now on bottom, now I have my numbers. So on bottom, I have a 3 and a 12. Well, this 27 is 9 times 3, so I can cancel those 3's. 12 is 4 times 3. And 8 is 4 times 2, so I can cancel the 4 and the 4. And then on bottom, I have left 3. Well, the 9 is 3 and 3, so I can cancel one of those 3's with that bottom 3. Now I have no numbers on bottom. No numbers on bottom, no letters on bottom. So I can take that out. I have a 3 and a 2 left on top, which is 6. So that all simplifies to 6xy cubed. Okay. Number 4 here, I'm just saying where it's undefined, like I said on the first couple problems. I just set the denominator equal to 0, right? And I just solve this. Plus 2 plus 2. 3x equals 2. Divide by 3, so x equals 2/3. Or for which value of x is this undefined? At x equals 2/3 is it where it's undefined at. Okay, next one, where's the least common multiple? So that means I'm going to factor these because they're quadratics, right? There's a plus and a minus in there, so I want to factor them. So again, I can do cab. C times A is 42, and my B is negative 13, right? So what times what is 42 but adds to 13? That'd be 6 and 7, but because that's negative, they're just both going to be negative. So I get x minus 6 and x minus 7. So those are two of my factors, so that's going to make up my least common multiple. Then I'm going to factor this one. Again, my cab would be negative 18, and my b here is negative 3. So what times what is 18 but subtracts to 3 would be 6 and 3. And because that's negative, I'm going to make the bigger number negative. So my other two factors are x minus 6. Well, I already have that written, right, over there. And an x plus 3. So that means my least common multiple would be all four of these, but since x minus 3 is repeated, I only need it right at once. So I just need to add to this x plus 3, and there's my least common multiple, those three factors right there. Okay, number 6. Just adding fractions, so I need common denominators. So I find that least common multiple. So this is my only factor of this left one, x minus 2. And x plus 3 is this one. So that means my LCM is just going to be x minus 2 times x plus 3. So there's my common denominator. And I just look and I see which one is missing. So this denominator is missing an x plus 3. So I want to multiply top and bottom by x plus 3. On bottom, I kind of already did it, right? Because it's in my list. But if you want to write it down, you can like that. So 5 times that. So 5 times x is 5x. 5 times 3 is 15. And And so that would be the new denominator. Why does it keep on doing that? X plus 3. And then my second one, this one I'm going to multiply by x plus 2 because that's what the LCM is missing. Or that's what this denominator is missing from the LCM. And then x plus 2 on top as well. Again, you got to be careful here. This is a plus, so it's just take the 4 and distribute it to both of them. So 4x plus 8. Sometimes when there's negative, you want to distribute the negative, like what we'll see on number 7. Now it's over that common denominator. And now I can combine like terms. I'm adding them, right? So 5x plus 4x is, I'll just put it over here, is 9x. 15 plus 8 is 23. And then common denominator. All done. Okay, this one, we already have common denominator, so that's kind of nice, but if you didn't, you do the same thing as 6. Write your LCM. Usually it's going to be the multiplying of these factors, but since they're the same, we already know what the common denominator is, so the only thing I got to really be careful of is this negative, so I have to distribute both to the x and to the 2, and to the negative 2. So we have negative 2x minus 1 minus x plus 2 over that common denominator, x plus 5. So simplifying, I have negative 2x minus another x is a negative 3x plus 1. Negative 1 plus 2 is a plus 1 all over that common denominator. Okay. Number 8. Maybe number 8. I don't know what just happened. There's number 8. Here we have fractions inside fractions. Don't know what's going on with this. But, so, whenever you're dividing by another fraction, you can flip it just like kind of we did on number 3 here. Okay, so we're going to take x plus 3 over x minus 1 divided by x minus 3 over x minus 1. I'm going to flip that bottom one, so x minus 1 will be on top, and then I'll be multiplying. So then these will cancel, x minus 1, and multiplied by x minus 1 and divided by x minus 1, so those are going to cancel. So then I'm just left with x plus 3 over x minus 3. Same thing with this. I can flip that bottom one, so x squared minus 9 over x plus 2 times by x squared plus 2x over x minus 3. So here we need to factor first before we cancel. All right, so I want to factor the top here. It's a difference of 2 squares, so x minus 3, x plus 3. And then this one I can factor out an x. So we get x times x plus 2 over x minus 3. So then x plus 2 will cancel, x minus 3 will cancel. We just get an x times x plus 3. So x times x plus 3. And there we go, we don't have a denominator there. Perfect. Okay, this one, what is excluded value? So when it says excluded, that's when you're going to do x is not equal to. So again, but all I have to do is just take my denominator, set it equal to 0, and solve. So subtract 3 on both sides. X equals negative 3, or x cannot equal negative 3. Then this one, I take 4x minus 9, and I set it equal to 0, and I add 9 to both sides. Divided by 4, so we get 9 fourths. So x cannot be 9 fourths. Okay, graphing. Remember, this is kind of the easiest type of graphing. We look what's being added to at the very end after the fraction. That's our horizontal asymptote, so nothing's being added. So that means y equals 0 is our horizontal asymptote. And then our vertical is just setting the denominator equal to 0. So x equals negative 3, so I go 1, 2, 3. That's a little off. There we go. So x equals negative 3. And now we can just find our branches, what our two branches are. So, nice. So what we're going to do is we're going to just either pick a number to the right of -3 and to the left of -3, or you can square root that top. So this one would be easier, just plug in -2. So x plus 3 over 3, I'm going to plug in -2 in for my x. So that's going to get me 3 over 1. So I plugged in -2 and I got out a 3. So I'm going to graph that -2. So 1, 2, and a 3. 1, 2, 3. So that means I'm in this branch, so I'm going to go down and I'm going to approach this asymptote, and then I'm going to go up and approach this one, right? If you don't know what it looks like, you can always graph more points. Okay, so if you don't know what it looks like, you can graph more points. Now I'm going to plug in a -4. So this time I get 3 over -1, which is a -3, right? So I got -4, -3 as a point. So -4, -3, 1, 2, 3. Okay, and then again I go up and approach this asymptote, and I come down and approach that one. So those are my 2 branches. All right, this one a little bit different. See how we're adding 1 to this at the outside? So that means that our horizontal asymptote is actually going to be y equals 1. So going across horizontally, y equals 1. Now my vertical is just setting that denominator equal to 0, which we kind of already did right here. Right, so that's 9/4, so that'd be what, 2 1/4. So 2 1 2 1/4, so somewhere like right here. Doesn't have to be necessarily so precise. X equals 9/4. Then again, I can plug in numbers, right? So here, this one I really want to do plug in numbers with this one. Notice that I just have x plus 3. So because it's just a plain x, I could really just take that top number and square root it, and that would give me my closest point. And that would just go over square root of 3, up square root of 3, get the closest point, and then go down square root of 3, left square root of 3, down square root of 3. But it's a square root of 3, so we don't really know it. So it's easier to just plug in numbers. All right, so I can plug in numbers. What's going to be the best is probably we want numbers close to 9/4, so around 2 1/4. So really we probably want to plug in just 3. So 4 times 3 minus 9. So that would be 12 minus 9, which is 3. So 1/3 plus 1. That's just 1 1/3, correct? So I'm gonna plug in 3, and I'm gonna get out 1 1/3. Right? So I'm gonna go over 3, 1, 2, 3, and then go up 1 1/3. So I'm a little bit higher than my 1, correct? So somewhere right there. So I want to approach this one, and then I want to approach this one. Okay, and then second, I guess I'm going to switch colors here. So instead of plugging in 3, I'm going to plug in 2. So 4 times 2 is 8 minus 9 is a -1, right? So I get -1 plus 1, I get 0. So I get 0, so I plugged in 2 and I got out 0. So I go over 2 and I get out 0. So about right there, I approach that one, and I approach the horizontal right there. If you want to, again, you can plug in more points. Big points, plug them in, see what you get. You should get your 2 branches. Always need a vertical asymptote, a horizontal asymptote, and your 2 branches with 2 points, at least 2 points. Okay, there you go. There's the video.